So I will just try to, I will talk about how to solve this type of question. First, I will give you an example. Let's solve 0 to x3 dx. So if you are familiar with complex analysis, we will see there's three poles. Poles are at x3 equals to -1 or equal to -i2n plus 1 pi. A different way to express the same thing, and you will have -2n plus 1 pi divided by 3. If you're in the contour plot, if you're in a complex plane, you will have pi over 3 pi 4 pi 1 2 2 is 5. Yes. So in the complex plane, you'll find is here, which is 120 degrees, and pi over 2 130. Pi over 3 and pi and 5 pi over 3. That's a 3 pole. And as you can find, there's a pole on the real axis. Big problem, because we don't want to deal with that. Generally, we can just choose this contour. Different color. It's a generalized way. This is 3n. This is 2 pi over 3, which almost always works. And it always works for integer n. So in general, I will write in blue. It will be 2 pi over n in general. And for this, I will talk about general case in the future. The pole will be from here. We'll see it will be x equals to e to the I 2n. Sorry, 2m. M is another integer, plus 1 pi over n. As a pole. And the contour is that real line and circle. So we got this. We already plotted out, so let's not worry about this. It will be easier to calculate anyway. Just have this. It's equals to the whole contour, which could be easily calculated. Use a Cauchy-Riemann integral. minus this arc and this arc. Same integral. So let's study each one of them. This is a residue, 2 pi I of the residue. You just divided by 1 minus the pole. Pretty much thus the residue. It will be minus e to the minus I2 pi over 3 e to the pi over 3 divided pi over 3 minus e to the I pi 5 pi 3. It's maybe heavy to calculate, but we will leave it like that. And C1 is the easiest one to calculate. There's an arc from 0 to pi over 2 pi over 3, 1 plus r squared e to the third e to the 3 theta. Plus dz is r I e to the I theta d theta. Because you need to do d e to the I theta. And r is constant. From here, you'll find for limit r equals to infinity, it will just become apparent and this number is definitely going to go to 0. So this is done. This is equal to 0. Not surprised. Which is type 1, which I will talk about in the general solving problem. let's do the number 2. Pardon me. Need to refresh my memory. So this could be written in a tricky way. What would that be? So we'll go from infinite 0 to infinity. 1 plus r, the third e to the I 3 theta. Here, theta equals to 2 pi over 3, and so we have e to the I theta dr. Because the theta doesn't change here. From here we could have some tricks. Three theta and it's a happy coincidence. We have e to the 3 theta equals to e to the I 3 dot 2 pi over 3 equals to e to the I 2 pi. I 2 pi equals to 1. Then we ended up having e to the I theta 0 to infinity. Sorry. Infinity to 0. So you can change it to negative 0 to infinity. 1 plus r3 dr. There's a negative here. So I ended up become negative e to the I theta 0 to infinity dx 1 plus x third. So it's the same thing. Then let's rearrange everything. We'll have 0 to infinity 1 plus x to the third dx equals to the total integral minus minus e to the I theta integral to 0 to infinity dx 1 plus x to the third. Then you have 1 plus e to the I theta 0 to infinity 1 plus x to the third dx equals to the you have 1 plus e to the I theta integral 1 plus e to the theta equals 2 pi over 3. That's that. So you can solve, you know the residue, you know the theta, utilize theta, then you have the final answer. A good check, of course, the final result has to be a real number. So this better give, I haven't tried it, but I might give us some really neat way to express it. Let's see. So we're left with this solution. 0 to infinity, 1 plus x to 3, dx equals to 1 plus e to the I 2 pi over 3 over 1. Sorry, this handwriting is not the best, but I will write a neat form of the general form. Hopefully it will be helpful. So in general, this theta is general in a way. So we can write 0 for the x to the n scenario. Thus, I 2 pi over n and multiply and the residue, I believe, could be written in a more pretty minus 1 pi over n, because you multiply by 2 times. Minus 2 e to the I, that's 2, so n minus 1 over n pi multiplied by m. So it's m from 1 to n minus 1, so multiply 1 minus e to the I m pi n minus 1 pi over n. That's a general form, I believe. And you can definitely check. In any event, the general solution is just like that. You just include one pole in it, and the second trace will be like 2 pi over n. It always will give you on the C2 this will be 2 pi over 2 pi because of this structure. Because you multiply by n, you multiply by n divided by n here, then it will be 1, and you ended up left with 1 e to the I theta, and then this and this will be off by e to the I theta, negative e to the I theta. Then you can solve for the whole equation using the residue theorem. Yeah.